Now, I confess, I borrowed my title from a 14-year-old Nathan Zohner's science fair project titled, How Gullible Are We? He was able to get 43 out of 50 ninth graders to vote in favor of banning dihydrogen monoxide, also known as water. The hoax was a science fair project. He not only won the science fair, but it inspired the term Zhonerism, defined as the use of a fact to lead a scientifically ignorant public to a false conclusion. Zohner was able to convince students by using half-truths. He ignored the truths that dihydrogen monoxide is critical for plants to grow, for your blood to flow, or fish to swim in the sea. Instead, he spun negative facts, such as dihydrogen monoxide is causing corrosion in our pipes and metal infrastructure. Dihydrogen monoxide can rot people's houses, causing thousands of dollars of damage every year. And when it's extreme, dihydrogen monoxide can cause suffocation and death, meaning drowning. And now scientists have found that our reservoirs have an enormous concentration of dihydrogen monoxide. And that was enough to convince all these ninth graders to ban the water. Are we victims of similar half-truths that are often pushed by politicians? Indeed, we are. And the only way to confront that and refute these Zohnerisms is by using reproducible science. Science, as described by Carl Sagan, is a way of skeptically interrogating the universe, understanding human fallibility. If we are not able to ask skeptical questions, to interrogate those who tell us that something is true, to be skeptical of those in authority, then we are up for grabs for the next charlatan, political or religious, who comes ambling along. Albert Einstein said something very similar, that unthinking respect for authority is the greatest enemy of truth. Now, regards climate change, the greenhouse effect is reproducible, settled science. Since the 1800s, scientists have definitely shown within laboratory experiments that water vapor and CO2 can absorb infrared heat waves and emit those heat waves and cause a warming effect that delays the cooling of the earth. What is being challenged is unsettled, non-reproducible narratives, such as exceeding 1.5 degrees Celsius of global warming will cause a climate crisis. That 1.5 degrees of warming is all greenhouse gases and ignores how much is contributed by natural variability. And showing that extreme weather events are caused by rising greenhouse gases. So for example, and I've suffered this, I've had people email me and call me and say that I am causing climate change to cause human extinction for simply being a good skeptical scientist. The fact that leads someone to believe that is that CO2 has a warming effect, and I agree. The other fact is that heat waves can be deadly. I agree. But the Zohnerism is that 7 million people die each year from global warming. Now, the main perpetrator of such a Zohnerism has been John Kerry, Biden's past climate envoy to the United Nations. And he claims it's indisputable of a climate crisis that threatens life on the planet itself, and that 7 million people a year die around the world from greenhouse gas pollutions. Now, this is troubling for me because at one time, John Kerry was my hero. We both grew up in Massachusetts. In the 60s and 70s, I was an anti-Vietnam War protester, and when John Kerry came out against the Vietnam War, I looked at him as my hero. Now, based on his allegations, I can only see him as one of the charlatans that Carl Sagan has warned us against. Kerry has no background in the sciences that allows him to accurately evaluate climate change. He has a political science degree, looking at policy and debates. And so it reminds me of a quote from W.C. Fields, that if you can't dazzle them with scientific brilliance, then baffle them with bullshit. And Kerry is definitely pushing bullshit. For instance, cold-related deaths happen 10 times more than heat-related deaths, and this has been reproduced in several top medical journals. A politician should be worried about how to keep us warm, not saying that warmth is causing more deaths. Likewise, if you look at the International Disaster Database, which keeps track of climate-related deaths due to floods, droughts, wildfires, and extreme weather, it is decreased by 99%, suggesting that better awareness in a warmer temperature has benefited humanity. Now, one of my favorite authors and journalists and economists is Thomas Sowell. And he said that good con men, what they do is they try to enable gullible people to continue to believe what they want to believe. And an example of a con man Zohnerism is that rising CO2 causes more heat waves. Well, if you look at the EPA data, its heat index that tracks the intensity and frequency of heat waves, we see that there is no trend. There was a tremendous amount of heat waves in the 30s, partly due to the Dust Bowl. But you look at the 1900s, the index shows it is no greater in the 1900s than in the 2000s. But if you want to make people believe that CO2 is causing it, you give a slightly different graph using partial data, as the EPA has done. What they've shown is just the heat wave frequency, starting since the 60s, the low point, and shows it has been gradually increasing up into the present day. And that correlates with CO2, thus promoting the Zohnerism. Now, there's been an arbitrary threshold of 1.5 degrees Celsius for temperature anomalies for the entire globe, suggesting that once we exceed that we're in a climate crisis. And this has scared our children to such a degree that you see them out protesting that, you old people are going to die from old age, but we're going to die to climate change. These young people are probably the most vulnerable to these kind of Zohnerisms. Averaging global temperature anomalies is what enables a lot of these Zohnerisms. If we break down temperature change for the last 120 years in the United States, and we break it down by seasons, we see something very peculiar. The greenhouse effect works as the sun heats up the surface, it causes infrared radiation to be emitted back towards space. The greenhouse gases will recapture some of that radiation and send it back to the surface and slow down the rate of cooling. So the warmer the surface, the more infrared radiation there is to recycle. So you would expect the summer to have the greatest greenhouse effect. But that's not what we're seeing with the temperature. It's the winter that has the greatest warming effect, and it's twice as much as what we see in the summer. Warmer winters will also reduce cold-related deaths, so it doesn't seem like this is a crisis to have winter warming. Another example of how averaging temperatures hides non-CO2 climate dynamics is you'll see summer temperatures in these cities showing a steady upward trend that they say correlates with more fossil fuel burning. But if you break it down, if you look at satellite data that uses infrared cameras to see what's the hottest part of the greater Atlanta area, you see some neighborhoods are 21 degrees Fahrenheit hotter than their neighboring. And why is that? Well, if you look at natural color variation, you see that the gray areas are the places where you have urbanization of lots of asphalt, lots of cement, very little vegetation. Those are the hot areas. The cooler areas are in green, and they are much cooler. So it's not that CO2 is going to minimize any kind of heat wave effect in urban areas. You need better urban planning, more vegetation, or ways maybe just to subsidize poor people who might be vulnerable to this kind of urban heat islands and provide subsidized air conditioning for them. Doing CO2 changes will do nothing to prevent this problem. So a graph like this is a half-true Zohnerism when you blame CO2. Likewise, we see this rising temperature trend for the United States. But averaging temperatures, again, creates half-true Zohnerisms by hiding certain dynamics. If we look at the trends at each weather station, with at least 70 plus years of data, we see that 34% of the weather stations have cooling trends. Now, it's very peculiar that you would see cooling trends, the blue circles, adjacent to a warming trend, the red crosses. You can't blame CO2 for warming one place and cooling in its neighbors. It's more likely due to landscape changes. And this sort of bears out, if you look at the places where it's almost solid red, no cooling, those are the heavily urbanized areas, such as in the northeast coast or the west coast. And likewise, in the center, the eastern United States, it's been called a warming hole. And scientists used to say, well, CO2 warming is going to reduce that warming hole, but it has not done that yet, baffling many climate scientists to understand why this cooling is happening. Now, averaging temperature anomalies further obscures our understanding of how the climate is affecting people. We see in this data between 1990 and 2013 that in the Arctic the temperatures are rising very rapidly, causing average temperature there to be 3 to 4 times greater than the rest of the world. But is that a problem? Well, if you look at the average 1990 winter temperatures, the actual temperatures, not the anomalies, we see that it was minus 26 to minus 10 degrees Fahrenheit. If we look at the temperatures now after this tremendous amount of increase, the temperatures have risen to minus 22 degrees Fahrenheit. Now, that doesn't melt any more ice. That does not threaten any human beings with warmth, and that doesn't threaten our agriculture. These anomalies get used to present a very distorted crisis picture. And you get people like Bill Gates falling for this and thinking he can save the world by blocking the sun, by taking aerosols and chalk up into space and scattering it so it reflects the sun, as if blocking the sun is not going to be a problem. Because life loves warmth, it's hard to motivate everybody to vote against burning fossil fuels in global warming. So instead, the people that are pushing alarm are arguing that CO2 is causing a crisis, and that crisis is causing more extreme weather events that threaten people's lives. And almost every time you see a drought or a flood, they will connect it to climate change by arguing that the Clausius-Clapeyron relationship, which has been well studied since the 1800s, shows that as temperatures increase, the atmosphere can hold more moisture. And that's an undisputed fact. Daniel Swain has recently tried to change this natural variability into some kind of hydroclimate whiplash, and he's used a sponge analogy that even ninth graders could understand, saying if you have a big sponge, due to a warming atmosphere, you can absorb more water, causing more evaporation and drier conditions. Or you can squeeze that sponge out and release more water, causing higher precipitation. But this hydroclimate whiplash is not caused by bigger atmospheric sponges. It's this natural variability. So when you have droughts, when you have floods, if you don't look at how moisture is being transported, then both of these are half-truth Zohnerisms. Now, natural variable moisture transport is what does cause droughts and floods. If you look at the water cycle, the water is initially evaporated from the oceans, but 90% falls right back to the ocean. 10% is now transported to the land. And where it's transported is going to determine whether you have dry or wet conditions. So if we have moisture being transported and hits the Sierra Nevadas, we get a lot of moist habitat in the Sierra Nevadas supporting sequoias, but it causes a rain shadow. So on the other side of the Sierra Nevada, you have the Great Basin Desert, where it's very dry. Extreme weather attribution that does not account for this natural climate variability are half-truth Zohnerisms. For example, looking at how climate change has affected precipitation, a study by Kazemzadeh in 2021 looked at satellite observations of precipitation changes, and 88% of the Earth showed no significant change whatsoever. 6% showed drier conditions, meaning less precipitation, but most of that was over the ocean, not on the land where it would be effective. And only 6% showed wetter conditions. And if you look at the map, there's very small places that show wetter conditions, which is more likely due to local effects on precipitation. However, there is one place in northern India and Pakistan where eastern India, which used to be one of the wettest places in the world, is getting less precipitation. In western India and Pakistan is getting a lot more. And this is being jumped on as an example of climate change on a global basis. So, as Winston Churchill said, never let a good crisis go to waste. Well, the UN General Secretary Guterres, who is eager to push for global control, and they want a global crisis, they say today it's Pakistan and tomorrow it could be your country. And then CNN, that supports this crisis idea, they say, well, Pakistan is emitting less than 1% of the world's planet-warming gases, but now it's drowning. And to make you feel even more guilty, MSNBC News tells you that Pakistan floods highlight climate racism. But if you look at the science that's reproducible, and you look at the trends in precipitation in Pakistan, we do not see any trend towards more floods or more drought. And we see high variability, and probably that the time that we had the least amount of precipitation, not due to a bigger atmospheric sponge, was 1876. And this was probably the most deadly time because it created the Great Famine. And it happened during a very small atmospheric sponge, so it wasn't due to this increased evaporation, but it killed over 7 million people in the India-Pakistan area. And as people have been investigating that, they look at that 1876 drought was due to an El Nino. And that El Nino was able to change the way the air circulates around the world to cause worldwide droughts and famines, as highlighted by these rectangles. And so if they add up the amount of deaths due to a natural El Nino, it was 30 to 50 million deaths. So to better understand why we have these droughts and floods, I want to share an understanding with the three major natural climate dynamics that control how the Earth's moisture is transported, how it affects Pakistan and affects California. The first is the Hadley circulation in the intertropical convergence zone. Now, I asked my audience how many people are familiar with this, and not a single hand was raised. It's totally unknown to them, which makes them vulnerable to Zohnerisms. Well, the Hadley circulation is powered by the sun heating the Earth differentially. The strongest rays from the sun happen in the equatorial area, and that causes the winds to be pulled from the north and the south towards that region, taking moisture-laden winds, and when they meet, when the winds from the north and the south converge, they have no place to go but up. And this rising air cools and drops its moisture down to the ground. So beneath this narrow area of the intertropical convergence zone, 30% of the total precipitation in the world happens where the ITCZ is located. Now, it also, that rising air, now it's dry, it's lost its precipitation, and what goes up must come down as gravity demands. And so you have this air sinking to the north and the south, creating a high pressure system that brings drought. And almost every heat wave is due to a high pressure system where the sinking dry air has less clouds, more solar heating, and it prevents moisture from entering that area. To see how important this is, we simply have to look at the biozones, the life zones on Earth. Where the intertropical convergence zone has its biggest effect, we see the tropical rainforest with the greatest diversity of life. Where the descending high pressure systems happen, we see the world's deserts that are also modulated by rain shadow effects of the mountains. These deserts are not dry because it's hot. They're dry because this descending dry air does not bring it any moisture. They're hot because it's dry. It takes twice as much energy to warm moist land as it does to heat up dry land. So dry land heats up quicker, and that's where we have the record high temperatures. Death Valley, 134 degrees, but that was in 1913. Likewise, we thought there was a record in Libya of 136 degrees Fahrenheit in 1922. That's no longer the official record because there were some challenges to irregularities in reporting. And now with satellites, we can measure the surface. We can't measure the air temperature like at Death Valley, but we can measure the surface, and satellites showed that the surface was 177 degrees in the Lut Desert. The wet part of the Hadley circulation, the ITCZ, is what brings wet seasons and dry seasons, and it migrates with the change in where the sun's location is, due to the tilt of the Earth's axis. In our summer, the sun's direct rays move further north. And that's when the areas beneath the red area get all their wet season. The golden area gets a dry season. And then as the Earth orbits around the sun, the tilt of the axis makes the sun look like it's on the southern hemisphere. So now the red areas gets a dry season and the golden areas gets a wet season. But this axis is not always the same. It has a 40,000 year cycle where the axis tilts more and tilts less. So around 7,000 years ago, there was a greater tilt to the axis, and the ITCZ was much further north, and the Sahara was a savanna with lakes and abundant wildlife supporting many hunter-gathering cultures. As the tilt got less and less, the Sahara about 6,000 years ago turned to a desert area. Now, the second dynamic that I want to focus on before I talk about Pakistan more specifically is as the trade winds are pulled towards the equator, the Coriolis effect, the rotation of the Earth, causes those winds to curl to the west. So what that does is the winds sweep all the tropical heated water in the eastern Pacific and sweep it over to the western Pacific and into the Indian Ocean. So the hottest water in the whole world is this Western Pacific warm pool and Indo-Pacific warm pool, where temperature waters are 29 to 32 degrees Celsius, far from boiling that the UN has kind of pushed, or Al Gore has pushed. What that also does, if you look at the average temperature for here, we see that the Eastern Pacific has cooler temperatures on average compared to the Western Pacific. And this is what the natural condition of the Pacific Ocean is. And because you have this warmest water in the Western Pacific, you have, again, it causes this conversion of moisture-laden winds that rise and make heavy precipitation over Southeast Asia, the Asian monsoons. In the Eastern Pacific, you have descending dry air, which causes La Nina conditions that cause California and the United States to have drier conditions, to have drought conditions. When you have a La Nina event, it's very specific that as the winds pull the water towards the west, it draws up colder water from beneath, and the area within the red rectangle, will have average temperatures about half a degree cooler than normal, and they'll say that's a La Nina event. But in general, the oceans are going to be more like a La Nina-like condition. Now, the La Nina-like conditions or the neutral conditions are maintained by strong trade winds. And it has two effects. One, it causes a rise in sea level in the Western Pacific, which will make sea level a half a meter to a meter higher than it is in the Eastern Pacific. So if the winds relax, gravity is going to pull all that warm water back towards the Americas. Likewise, it causes warm water to be stored at deeper and deeper levels. And so you have this tremendous reservoir of warm water ready to slide back to the eastern part of the Pacific when the winds allow it to do so. So this is what causes the warmth to be released during an El Nino event, which every 3 to 7 years happens as the winds change a little. All that warm water starts rushing back towards the Americas, and now the center of rising convection happens along the Americas coast, or maybe it doesn't reach the coast, it just goes to the center of the Pacific. But that changes how much moisture happens. That's when we get our heavy rainfall, where the monsoons in Asia now have a drought period. And so we can see why the El Nino event caused that dramatic droughts and famine in the 1876 is because the moisture moved away from Asia and towards the Americas. When you have an El Nino event, it happens when within that red rectangle they measure a half a degree of Celsius higher than what's normal and average. And you can have it even higher than that. The third dynamic is the Madden-Julian oscillation. Instead of happening every 3 to 7 years, it happens every 30 to 60 days. The Indian warm pool likewise causes most of this rising convection to create all the rainfall over Asia. But as it does so, it also causes drying air to descend. So further to the east, you have descending dry air, fewer clouds, and greater solar heating of the ocean. And that causes the center of rising convection to shift towards the eastern part of the Pacific. So what we see is the Madden-Julian oscillation, and when it first is triggered, it brings lots of rainfall to India and Asia, but causes drought and dryness in northern Australia. But after a couple weeks, as that moves to the east, we now see that now the center of convection is over northern Australia, so northern Australia gets a wet period. And then a few weeks later, the same dynamic causes it to move further east, and Australia goes back to a dry period. We call it hydroclimate whiplash, but it's just this natural variability due to this oscillation. Now, all these dynamics that cause rising air currents, they can disturb the flow of the jet stream, and that can affect where dry and wet periods are happening. When you have an undulating jet stream at the ridge, it creates a high pressure system of air sinking. In almost every heat wave you see, the weatherman will tell you, oh, we have this ridge over here. And that's causing this heat dome due to the sinking air. As the jet stream now goes into a trough, as the air leaves, it diverges and it causes the air to rise. So this is where you get unsettled weather and wetter weather. And this wave is not just restricted to the United States, but you can have a wave like this go at least halfway around the world, if not longer. So if we want to understand how an El Nino event caused drought and famine around the world, we can look at this study from Rodriguez in 2019, trying to explain why South America has its most common severe droughts and marine heat waves. And it all started back when you had the Madden-Julian oscillation cause a undulating jet stream, which caused a pattern of high pressure areas that are dry and then low pressure areas that are wet. And as that moves along with this undulating area, we see that in South America, when the high pressure system gets focused over that, that's when you have your drought and your famines and your heat waves in the oceans. Now, consider all these three dynamics together, we can get a better picture of what's going on in Pakistan, other than greenhouse gases. If we look at the northernmost reach of the ITCZ in July, it favors eastern India and not Pakistan. And we see the yellow area to the upper left of just above the ITCZ. Those are the deserts of Pakistan. It doesn't get so much water. And for that reason, much of Pakistan is desert and suffers annual droughts. If we look more carefully, we can see how the winds carry the moisture. Eastern India is one of the wettest places in the world. It gets 400 plus inches of rain every year, and you compare that to California, which only gets 25 inches. The town of Monsoon in eastern India gets 467 inches of rain every year and is considered the wettest city in the entire globe. But because the winds take that moisture and send it eastward instead of westward, western India's towns like Bikaner only get 10 to 17 inches of rain, and Pakistan gets even less. The floods of 2022 showed a clear shift where the winds were moved by a La Nina condition, a Madden-Julie oscillation, and an atmospheric river, that in July and August, eastern India's rainfall was reduced by 20 to 60%. And western India's rainfall was increased, as was Pakistan's. So it was not something due to this bigger sponge, smaller sponge of global warming, but it was simply due to dynamics that are natural that shift where the rainfall is going to happen. So that's Pakistan. Well, how does that relate to California? Well, the ITC is still a critical component. Once you get outside the tropics, say 30 and 40 degrees, 45 degrees latitude, the winds shift from the trade winds that blow from the east to the west. Now they come from the west. And you would think these winds blowing from the west would bring lots of moisture to California. But California has a natural summer drought, which is what is the trademark of Mediterranean climates, that you see it has a symmetrical alignment to the north and the south of the equator. The reason this happens is when the ITCZ moves north, its high pressure systems that block moisture also move north. And they block the moisture that was carried by the trade winds, and that clockwise circulation pushes a lot of that moisture to the north. So you have boreal rainforest in Alaska and British Columbia because of this change in transport, where we get drought all summer, not a spit of rain during the summer. Similarly happens in the Mediterranean and in a mirror image down in the southern part of the world. In the winter, as the ITCZ moves southward, so do the high pressure systems. And now that those high pressure systems that were once a gatekeeper allow the rains to come, and that's why our winters are the rainiest time of year. Furthermore, those high pressure systems are affected by El Niños and La Niñas. When we have a La Nina effect, it's much drier. It intensifies that high pressure system, or it makes it last longer in a way that can block the rains and force the rains further northward. Where if we get an El Nino, that makes it a lot easier. So the fires we just had in Los Angeles area happened when we had a La Nina condition causing this drier conditions. Now, the other thing the ITC does is it affects atmospheric rivers. And 50% of California's rainfall is brought from the ITCZ up to our coast by an atmospheric river. What you can see here is the red areas where we have the most moistures, and these little spikes that are emanating out of it are called atmospheric rivers. And knowing that I was going to give this talk and there was an atmospheric river going to cause a big rainfall around January 31st, I took a screenshot from the National Weather Service computer models, and you see the lightest blue areas is where the ITCZ is. And you can see the atmospheric rivers that emanate out from that. And there's 3 to 5 of them happening in every hemisphere any day. Well, to show how much water vapor is in the air, what they measure the water vapor and imagine if they condensed it all and weighed it, how much moisture would be there. So over the warm pool, we see there's about 65 kilograms of water. You go over to the Eastern Pacific, it was only about 55. in the ITCZ. But you go to the Sahara Desert when you get away from the ITCZ, and it's down to 4.7 kilograms. Only 10% of the water is reaching there that was reaching other places. Now, the atmospheric river emanated out of a place just below Hawaii and then heads towards the California coast. So we call it the Pineapple Express. It interacts with the ocean, evaporating some water, dropping some, but by the time it gets to the California coast, it had only 33 kilograms. But that was enough to bring some heavy rains. But due to the rain shadow in the mountains that intercepted that atmospheric river, the Great Basin only got 2.4 kilograms. This is all, these measurements all happened within a half an hour of each other as I was scanning the weather model. You can see in the Atlantic, out of the Atlantic warm pool, there's another atmospheric river that's bringing lots of moisture to Iceland and built up a lot of snow, but by the time that moisture got to Greenland, it's only about 1.2 kilograms. So that's one of the reasons Greenland is called the polar desert. It doesn't get very much rain. It had less than what the Sahara got. Well, just before I came to this talk on March 12th, I took another screenshot from the National Weather Service model to show how these atmospheric rivers, in some ways they act like a garden hose that you lose control over, and it just squirts the water all over the place. Well, again, we see the warm pool had about 64 kilograms of moisture, and the same thing at the ITC in the Eastern Pacific. But we don't see as much moisture being brought up into the United States, and so it's only 22 is reaching it, and it's reaching it in a slightly different degree. Different high pressure and low pressure systems can trap and redirect the way this moisture is flowing. So if you look in the in the Atlantic, we'll see that a little more moisture was gone to the Sahara, but to Iceland, we're only seeing about 8.8 kilograms, and then some of it is redirected to the west side of Greenland, where Greenland is now getting 9 kilograms. So it's this tremendous variability of where snow falls in Greenland and Iceland is the way these atmospheric rivers are moved around by different pressure systems. Well, California's worst mega flood was due to atmospheric rivers that started in December and continued through January in 1862. A time when the atmosphere was cooler, less CO2, and was a small sponge. But we had the greatest floods we've had in the last 160 years. It was so bad that it flooded Sacramento, and the government seat had to move to San Francisco until that area dried out. Now, these worst floods are not due to global warming, not due to a large sponge. They're happening because of the way moisture transport happens. And because they're so damaging, they've been looking at these mega floods by examining sediments in lakes and in the bay. The more sediment, the greater the floods. And what they find is mega floods happen every 100 to 200 years. And we've seen them happen in the 1300s, 1400s, 1600s, 1700s, and 1800s. All little ice age, cold weather, low CO2 conditions. Extreme flooding is not correlated with CO2 warming. Now, if we look at the SPI, the Standard Precipitation Index, to see how much rainfall is reaching the Sierras, we don't see any trends due to CO2. What we see is high variability. And that variability you would naturally expect due to changes in El Nino, La Nina, and atmospheric rivers. It's just what we have to get in California. Well, people like Daniel Swain or Michael Mann, who are climate alarmists, have been trying to blame the tragedy of the Los Angeles 2025 wildfires on climate change and burning of fossil fuels. People like Daniel Swain say, well, it was due to a climate whiplash. When you had years earlier, it was more rainfall, which you would expect from El Nino-like conditions, which caused more vegetation to grow, and then you had a La Nina that made it drier. And he just changed it into a climate change thing instead of calling it natural variability. By blaming CO2, you're creating a half-truth Zohnerism. And likewise, because the lion's share of funding goes to researchers who were looking for a problem with CO2, we had this publication, CO2 Worsens Wildfire, by helping plants to grow. CO2 is the molecule of life. No photosynthesis, no trees, no food chain. but you demonize it, like a Zohnerism, by saying that CO2 is causing more plant growth and there you have more vegetation to burn. It's a half-truth Zohnerism. And it reminds me of another W.C. Fields quote, if you can fool some of the people some of the time, but that's enough to make a decent living. Well, if we look at wildfire history, it shows no correlation with rising CO2. This study by Swetnam in the southwest of the United States shows that fires in the 1700s and 1800s were far more frequent and burnt far bigger areas than they do today. And then around the 1900s, it started to decline. And the reason for that is the beginning of fire suppression to protect logging industries and protect towns that were building out into the wilderness. By 1930s, the Forest Service implemented what they call the 10 a.m. rule, meaning if they spotted a fire, they were going to have it put out by 10 a.m. the next day. And so by the 1980s, we see that there were hardly any fires in the United States. But what we realized was there's now this buildup of undergrowth that could make fires much worse and much more intense. But if you want to enable gullible people to believe it's all due to CO2, you print another EPA graph which shows since 1980 that wildfires have been increasing, even though it's nowhere near what it was in the 1700s and 1800s. It's due to changes in fire suppression. That now if fires don't threaten any structures, they'll let it burn instead of try to put it out. So again, a graph like this is a half-truth Zohnerism. Now, if you look at a map of where the biggest fires happen, fires over 300 acres. The small fires happen all the time and cities can put them out. The fire previous to the Pacific Palisades only burned 8 acres. So why is the Western United States have the biggest amount of big acre fires, the most burnt areas? Well, it's driven primarily by the type of vegetation and relative humidity. The Western United States has a relative humidity of about 20 to 40% on average. And that's due to the way the high pressure systems block the amount of moisture reaching it. The Eastern United States looks hardly any big fires, between 50 and 70% relative humidity. And the reason it's so much more moist is because the high pressure system in the Atlantic, its clockwise movement draws more moisture out of the Gulf of Mexico and brings it up into the United States. And that's why you get lots of rain in the summer in the Eastern United States and no rain in California in the summer. Now, relative humidity has this big effect on 1 hour and 10-hour fuels. A 1 hour fuel is like a dead grass. And you can have a twig its diameter is no bigger than the eraser on a pencil. Or you can have a 10-hour fuel where now you can have a twig that's its diameter is about the size of a quarter. It doesn't matter. Anything related to climate change is irrelevant. In one day, these fuels become highly flammable and cause a burn because they're sensitive to relative humidity. And you can test this at home if you think that I'm making stuff up, is take a piece of computer paper and soak it till it's thoroughly wet, then hang it up to dry. Or you might cut it into 4 strips and compare that with 4 strips of dry paper. And every hour check it and see how the changes in dryness and flammability happen. You'll see at an end of 4 hours that wet computer paper will be dry enough to burn like crazy, which is how these 1 hour and 10-hour fuels work. You just need 1 day of dry weather, which happens all the time. You don't need climate change. Now, to emphasize how easily these 1 hour and 10-hour fuels are ignited and spread fires, the Mendocino Complex fire happened in 2017. And it happened when a rancher was out in his fields pounding a metal stake, hit a rock, it sparked the dead grass around him. This happened midsummer. And turned out to be the 3rd biggest fire in California's history because it burnt all these grasses. It ignited so easily. And you compare that to a living tree. When a living tree gets hit by a lightning strike, the temperature of that lightning strike is 50,000 degrees Fahrenheit, 5 times what the surface of the sun is. Yet it doesn't cause the tree to catch on fire. It may cause moisture in the tree to vaporize and cause a scar like this, but it usually only ignites a fire if there's this grass and duff at the bottom that's easily ignited. And the reason is to get a bigger tree like this to ignite, you need more sustainable heat. And that's where fire suppression became a problem. If you want trees to burn, the undergrowth, the more grasses and shrubs that grew up underneath the forest, once they're ignited, and often the fire is carried into the forest by this grassland, once they're ignited, they can sustain that heat for long enough to cause trees to ignite. Now, the Cal Fire has studied the burnt area, and it breaks it up according to vegetation, and you see grassland fires are by far the greatest burnt area extent. And the more grassland we have, the bigger the fire. The more easily it's ignited, the more quickly it spreads. And that's what happened in the recent fires. If we also look at Malibu Canyon, now they get fires, 2 fires every 10 years. And what that has done is that converts places that are shrubs and chaparral, it kills them enough to bring in all these invasive grasslands. And so now in Malibu Canyon, it's much easier to ignite a fire, and it can spread much more quickly. Now, if we look at the vegetation in the land above, say, the Pacific Palisades, in the parks there, it's dominated by 1 hour and 10-hour fuels. There was a fire up in that area. It started by firecrackers, but it only burned 8 acres. You needed the Santa Ana winds to help spread it. And the Santa Ana winds happen every year between October and May, mostly. And it happens because the high deserts nearby cool very quickly relative to the Pacific Ocean that cools much slower. And it creates a high pressure system that pushes very dry winds down towards the ocean. And the Santa Ana winds are typically between 10 and 20% relative humidity. And this one, the weather people were reporting below 10%. That relative humidity quickly dried out all that 1 hour and 10-hour fuels, allowing this fire to spread like crazy. The same thing happened in these recent fires in the Carolinas. And people were amazed at how can you have these fires in the Carolinas? It's so moist. Well, it's not always moist. The Clausius-Clapeyron relationship is a two-edged climate sword. You can have it cause more evaporation, but colder weather means the winds have contain less humidity, and it brings drier weather. So in the Carolinas, it's these late winter cold fronts that bring cold air down from Canada. That reduces relative humidity to below 30% in February and March. In February and March, the cold seasons are the seasons that have the greatest fires in the Carolinas. And you compare that with historically, in 1898, 3 million acres burnt in the Carolinas versus the ones we just have now in February and March, they only burn about 8,000 acres. So again, it's not global warming. It's not climate change. So what roles does climate warming play? Well, if you're a land manager, one of your best tools to eliminate this undergrowth that happens beneath the forest and grassland and shrublands that easily carry fires, you use prescribed burns. But if the fuel moisture gets below 8%, then there's extreme fire danger. And land managers will cancel a prescribed burn because that burn, just small embers, can spark the vegetation down the road and you can have a fire get away from you. So typically a land manager will have some kind of table like this to reference changes to estimate the fuel moisture. And so they have a table that has relative humidity going from 0 to 100% and temperature between 10 degrees Fahrenheit and 109 plus. And how does that affect fuel moisture? Well, as the Santa Ana winds brought dry conditions relative humidity to 10 to 14%, fuel moisture drops to 2%. Incredibly dry, highly flammable, easily ignited. It has nothing to do with climate change because that 2% relative humidity will cause that, whether it's 10 to 29 degrees Fahrenheit or 109 degrees. Temperature is not the issue. Likewise, when you have a relative humidity of 25 to 29%, which happened in the Carolina fires, fuel moisture drops to 5 to 4%. And there's a little effect of temperature. If it's over 70 degrees, it drops to 4%. And under that, it's 5% moisture. Both cases, highly flammable. Climate warming is irrelevant. Temperature is irrelevant in these cases. And you can see with fires, when you get relative humidity to 70% or higher, as you do in the eastern United States during the summer, now you get fuel moisture that is above 8%. It's in the 10, 11%. And that slows down how easily fuels are ignited and how quickly they can spread. It's why you see fewer fires in the eastern United States. Now, Michael Mann went on and said, well, this global warming is really what's causing fires, and it's causing fires to now burn in the winter, which is totally ridiculous. It's basically bullshit. The reason we see fires all year round now is due to human ignitions. The natural fire season, the lightning season, peaks between June and August. The winter's very rare. You don't have the lightning. In Southern California, lightning, all the fires there are really caused by humans. But we see the humans in the red area is when you have this tremendous peak. And it's because wildfire ignitions, if you have increased human populations, you can have more accidental fires. You can have more arson. You can have a greater electrical grid, which has caused many of these fires that are susceptible to high winds. And you can have a more easily ignited landscape because you've disturbed the soil, you've brought in invasive grasslands, you combine that with natural dryness, and you have tremendous fires. So sleep well tonight. There is no climate crisis.